Chapter 11.2, Proving Figures Are Similar Using Transformations. Okay, so just a quick review about what similar figures are. Hopefully you remember a lot of this from middle school and from previous chapters that we've looked at. But when you have two figures that are similar, that means that their corresponding angles are congruent and their corresponding sides are proportional. And the symbol for similar is that little squiggly line right there. This is saying triangle ABC is similar to triangle DEF. All right, a basic explanation is that when two figures are similar, they're going to be exactly the same. The only difference is that one could be bigger or smaller than the other, but they're going to look exactly the same, and one of them might be bigger or smaller. But that means that their corresponding angles are congruent and their corresponding sides are proportional. What this chapter is about is if two figures are similar, that means that there has to exist a transformation that you could do to one figure to put it on top of the other figure. All right, which we'll look at in a second. Okay, un repaso sobre qué quiere decir similar cuando dos figuras son similar. Okay, eso quiere decir que los ángulos correspondientes son congruentes y los lados correspondientes son proporcional. En otras palabras, si dos figuras son similar, eso quiere decir que lucen igual. La única diferencia es que una figura puede ser más grande o más chiquita que la otra, pero lucen igual y los ángulos miden igual. Y ahí esa línea, ese es el símbolo para similar, ¿ok? Esto está diciendo que el triángulo ABC es similar al triángulo DEF. Este capítulo se trata de que cuando hay dos figuras similares, si son similares, eso quiere decir que tiene que existir una transformación que pone una figura encima de la otra figura. All right, so a similarity transformation is a transformation in which an image has the same shape as its pre-image. Similarity transformations include reflections, translations, rotations, and dilations. Basically, all the transformations that we've studied. Okay, several chapters before, I talked about rigid transformations, which were these three, but did not include dilations. Because in a rigid transformation, it stays the same size. The figure stays the same size. But if we're talking about similarity, then it's all of these transformations as well as dilations. Two plane figures are similar if and only if one figure can be mapped to the other through one or more similarity transformations. All right, so in this example here, it says describe the transformation you can use to map vertices of garden RST. All right, they're talking about a garden, but they should have used the word triangle. All right, basically triangle RST, which is the big one. All right, to map triangle RST to the corresponding vertices of triangle DEF. Let me do that one in blue. All right, so we're starting with the big one and we're making it smaller. So if it appears to be the same exact shape, just smaller. So that means that yes, they're similar. Okay, so they want to know, okay, so did you do a reflection, a translation, a rotation, or a dilation to make it smaller? It's a dilation with a scale factor of 1/2. How do we know that the scale factor is 1/2? Okay, look at the red triangle RST, and pick an easy side. Pick an easy side to look at. The only easy side to look at is this one, because it's horizontal. So I could just count how long it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so side RT is 12 units long. And in the blue triangle, side DF goes from -2 to +4, so it's 6 units long. Okay, so remember in the previous chapter, to get scale factor, I mean, I don't think it's necessary to write all this out, but just to review what we did last chapter, okay, to get the scale factor, you would put the new side over the original side and simplify. So 6 over 12, 6 over 12. When I divide the top and the bottom by 6, I get 1 over 2, all right? Another way you could have done it is just say that, hey, what do you multiply 12 by to get 6? You multiply 12 by 1/2 to get 6, all right? 12 times 1/2. Sorry, the tablet I use to write is when I write on the right hand side, it tends to mess up if I'm not careful, or maybe I'm just doing something wrong and I don't realize it. But 12 times 1/2, if I write slow, it works better. 12 times 1/2 is 6, all right? So the scale factor is 1/2, all right? That's an easy example of what you're going to be doing in this chapter. I'll do more examples in a second. Let me just try to repeat that as quickly as I can in Spanish. Okay, así que en este capítulo están hablando de transformaciones de figuras similar. Si son similar, quiere decir que tiene que existir una transformación que convierte la figura original a la nueva figura. Las transformaciones que se usan para figuras similar son reflexiones, traslaciones, rotaciones y dilataciones. Ok, así que en este ejemplo tenemos el triángulo RST y el triángulo DEF. Los dos son similar. Así que, ¿qué transformación se puede hacer para convertir el triángulo RST al triángulo DEF? Y es una dilatación de un factor de escala de 1 sobre 2. Si se fijan en el lado RT, que mide 12 unidades, y ese lado corresponde al lado DF, que mide 6 unidades. Así que el factor de escala, que lo aprendieron cómo hacer en el capítulo anterior, se encuentra comparando el lado nuevo al lado original, que es 6 sobre 12, que cuando se simplifica te da 1 sobre 2. O también pueden pensar de 12 se multiplica por cuál número para coger 6. ¿Ok? Se multiplica por 1 sobre 2 para coger 6. All right, so look at this example, all right? In this example, okay, it says you could represent dilations using the coordinate notation. All right, notice something here. Okay, the letter K is important. The letter K represents the scale factor. So look, if by any chance this looks complicated, it's not. All they're doing is saying, hey, get the X and the Y coordinates, and you put the number that you're dilating it by in front of X and Y. Okay? So K is the scale factor. K is the scale factor. And the center of dilation is the origin. Okay, now look what it says here, okay? Because I mentioned this in the last chapter as well. If you're making a shape smaller, you got to multiply by a number that's less than 1 but greater than 0. That's what it says right here. If the scale factor is greater than 0 but less than 1, then the dilation is a reduction. You're making the shape smaller. But if K is greater than 1, then the dilation is an enlargement. K cannot be a negative number, okay? So if you're making a shape smaller, you multiply by a number that's less than 1 but greater than 0. And if you're making the figure bigger, you multiply it by a number that's greater than 1. Believe it or not, understanding that basic idea will make your homework a lot easier, because there are multiple choice questions where if you just see, oh, the shape is getting bigger, there's only going to be like one option that's multiplying by a number greater than 1. And if you're making the shape smaller, there's going to be like one option where you're multiplying by a number less than 1 on the homework and on exams as well. All right, so just realizing that will save you a lot of work if you understood that concept right there. All right, now let's look at this, what they're doing here, okay? Because this is also important and simple. All right, they put the coordinates of the pre-image right here, triangle RST. In this case, it's the little one, triangle RST. Here are the coordinates, okay? And here are the coordinates of the image, which is the bigger triangle, triangle XYZ. Okay, now let's look at the coordinates, and you could tell from the coordinates what number they're multiplying by. Okay, 1 times what number will give you 3? Over here, 1 times what number will give you 3? Negative 1 times what number will give you negative 3? Negative 1 times what number will give you negative 3? Negative 1 times what number will give you negative 3? The answer to every question I just asked is 3. And over here, 0 times 3 equals, hey, 0. Because 0 times anything is 0. So with the zeros, you can't really tell what the scale factor is. But with every other number, if you look at the corresponding number from the pre-image to the image, they're all being multiplied by 3. So the scale factor is 3. K equals 3. I hope you realize that because, again, that's simple. All right, I'm trying to show you that every number on the left is being multiplied by 3 to get the number on the right. The only coordinate that doesn't help us to figure that out is the 0 to the 0. All right, that one doesn't allow us to figure out what is the scale factor, but all the other ones, they're being multiplied by 3. And so is this one. We just can't tell what it's being multiplied to get 0 because 0 times anything is 0. All right, before I move on, let me repeat that all this in Spanish. Okay, en español, dice aquí que pueden representar una dilatación usando la notación de coordinados, que ya lo hemos estudiado este año, ¿ok? Donde x, y se convierte a k multiplicado por x, k multiplicado por y, ¿ok? Eso no es complicado, a lo mejor luce un poco complicado para algunos de los estudiantes, pero no es complicado si me ponen atención. K representa el factor de escala. Ok, K representa por cuánto están multiplicando los coordinados de X y Y para hacer la figura más grande o más chiquita. Si K es un número menos que 1, pero más grande que 0, la dilatación es una reducción. Ok, y si K es un número más grande que 1, la dilatación es, no sé cómo traducir esta palabra, pero la dilatación está haciendo la figura más grande. Ok. Ya eso yo lo he dicho antes. Así que básicamente si una figura lo van a hacer más grande con una dilatación, se tiene que multiplicar los coordinados por un número más grande que 1. Y si lo van a hacer más chiquito, se multiplica por un número menos que 1, pero más grande que 0, porque no se multiplica por un número negativo para hacerlo ni más grande ni más chiquito. Ok, y aquí están enseñando en este ejemplo cómo se puede encontrar el factor de escala simplemente analizando los coordinados, que es bien posible que tengan eso en una pregunta. Este ejemplo es fácil. Si miran los coordinados, todos menos el 0, no se fijen en el 0 hasta que yo lo explique en un momento, pero todos los otros coordinados, si se fijan en los números, se están multiplicando por 3. 1 por 3 me da este 3 aquí. Este 1 por 3 me da el 3 que está aquí. Este negativo 1 por 3 me da negativo 3, etc. Ok, todos los coordinados se están multiplicando por 3. Este 0 también se está multiplicando por 3, pero este 0 no nos ayuda a encontrar qué es el factor de escala porque 0 multiplicado por cualquier número te da 0. Así que si con solamente ese no puedo encontrar el factor de escala, pero con los demás sí se puede encontrar. ¿Okay? También se puede encontrar fijándose, comparando este lado a este lado, pero si le dan solamente los coordinados, tienen que saber cómo hacerlo de esa manera también. Vamos a mirar otros ejemplos. Okay, so look at this one, guys. Same type of question I just did. We got to fill in the blanks. All right, they give us some of the coordinates of the pre-image and some of the coordinates of the image. So let me do this first. Let me fill in the blanks. ¿Ok? Nos dan algunos de los coordinados para el pre-imagen y el imagen. Déjame poner lo que falta. Ok, so the pre-image is PQ. This is the pre-image right here. PQRS. PQ. All right, it's going clockwise, so I'm going to put R here and S here. R is at 6, 4, and S is at 6, 2. All right, now let me fill in for the image. If I go in the same direction, and this would be W, X, Y, Z. It's also in alphabetical order. So W is 5, 5. Y is 12, 9. All right, so let's analyze look at the coordinates and see if you recognize what the scale factor is. It's going to be a fraction, right? I'm going to show you how you can figure it out. Okay. Miren los coordinados para ver si se dan cuenta que debe ser el factor de escala. Es una fracción, así que si no se dan cuenta cómo encontrarlo, ahora le explico. All right, look how you could use basic algebra to figure out what the scale factor must be. All right. 2 times a number has to equal 2 times, let me put 2 times a number has to equal 5. I'm just using this one right here. Like this 2, I got to multiply it times something to get 5. El 2 lo tengo que multiplicar por un número, por el factor de escala para coger 5. Alright, so basic algebra, 2 times n has to equal 5. That means n has to equal 5 over 2. If you thought 2.5, that's correct as well. Okay, if you simplify it, I would leave it. Usually they make you use fractions, all right? So make sure you're aware that it's 5 over 2. But if you thought 2.5, that's correct as well, okay? 2 por un número me tiene que dar 5. Si comparo cómo convirtieron este 2 a este 5. Así que uso álgebra básico para encontrar qué número se multiplica por 2 para coger 5. 2 por n es igual a 5, así que n es igual a 5 dividido por 2. Que si lo divido es 2.5, pero casi siempre quieren que usen fracciones, así que entienden que es 5 sobre 2, ¿ok? El factor de escala. All right, so find each distance. PQ equals 2, QR, where's QR? QR is 4, WX is 4, and what equals 7? It has to be XY, I guess. 1, 2, 3, 4, 5. Yeah, so XY is 7. 3, just making sure I counted right. Okay, so if K PQ equals WX, yeah, they make this sound kind of complicated, but then K equals 2. However, oh, you know what? I kind of did this work for nothing. I may have to delete that. All right, you know what? Before I continue, let me just show you something. These, maybe I should have looked at this first, all right? Let me erase everything for 1 second. Sorry about that. I may or may not leave this in. All right, I should have done this first. Okay, when I look at these two rectangles, this side is 2 and this side is 4, right? So that means that if these two rectangles are similar, then every side down here, you got to multiply it by 2 to get this rectangle, because 2 times 2 is 4. However, when I look at the horizontal sides, this one is 4. And when I multiply it times 2, I don't get what this side is. This side is 7. So therefore, these are not similar. So what I was explaining up here is correct. However, I didn't look at all the coordinates. I just assumed that it was similar. And I was wrong to assume that because these two shapes are not similar. All right? So keep that in mind because you may get that on your homework. I should have done that first. But whatever. I'll leave it because what I explained was similar. I'll leave it because what I explained was useful. All right? For other problems that we're going to do today. Okay? No me di cuenta que si comparo estos dos rectángulos no son similar. Debía haber hecho eso primero. Ok, porque si miran a este lado aquí, lado PQ, ok, mide 2 y este lado WX mide 4. Así que si los dos rectángulos son similares, eso quiere decir que todos los lados de este rectángulo se multiplican por 2 para tener este rectángulo. Pero cuando miramos este lado, que mide 4, el lado PS mide 4, y ese lado corresponde a este lado, WZ. Si yo multiplico 4 por 2, este lado debe medir 8 y no mide 8, solamente mide 7. Así que estas dos figuras no son similares. Lo que yo expliqué aquí estaba correcto, pero yo estaba asumiendo que las dos figuras son similares y no son similares. Así que déjame seguir para otro ejemplo, porque estas dos figuras no son similares. All right. Okay, so it says here, determine if the two figures are similar using similarity transformations. Tenemos que determinar si las dos figuras son similar. Okay, so the way I'm going to do this is by comparing their coordinates. for the pre-image and the image. Another way you could do it is by getting the distance of each side using the distance formula, but that's more work. What I'm going to do is less work. You should always work smart. Work smart, like recording your lessons on video and putting them on YouTube. All right, all right. Let me put the coordinates E, F, G, H. I'm gonna put the letters in alphabetical order because that's usually how they do it. So E is at 0, comma 1. F is at 1, comma 0. G is at 0, negative 1. And H is at negative 1, comma 0. All right, and if I use the other one going in alphabetical order, A, B, C, D. Okay, so A is at 0, comma 4. B is at 4, comma 0. C is at 0, negative 4. And D is at negative 4, comma 0. So are the two figures similar? What do you think? All right. Aside from the fact that they look similar, if you look at the coordinates, you should realize like 1 times what is 4? 4, right? All right. So let's start with that theory that if 1 is being multiplied by 4 to get this coordinate, if the two figures are similar, that would have to mean that every coordinate is being multiplied by 4 to get this coordinate. All right? So test out the theory. 0 times 4 is 0, 1 times 4 is 4, 0 times 4 is 0, 0 times 4 is 0, negative 1 times 4 is negative 4. Okay, yes, the theory is correct. The two figures are similar. Oh, this thing is acting up, sorry. Similar. Okay, and the scale factor, K, all right, the scale factor is 4. Sorry. The scale factor is 4. Okay. Así que si comparo los coordinados del pre-image y el image, okay, se deben dar cuenta que todos los coordinados se están multiplicando por 4. Así que es una dilatación por un factor de 4. If I had to write the rule for this, I would write it like this. This is really frustrating me. I'm sorry. I would write xy becomes 4x, comma 4y. Alright, si tendría que escribir la regla, lo escribo de esta manera. XY se convierte a 4x por 4y. Porque K, que es la factor de escala, es 4. Alright. Alright, so there's my answer. Moving on. Alright, so look, this one, are the two figures similar? This is how I would do it. They're not, okay? They're not. How do I know it? Because look at this side right here. Always try to compare the horizontal and the vertical sides because those are easy to look at and compare. Alright, this side on here, side QR, is 3 units long. And that side corresponds to side TU, which is 1. So if the two triangles are similar, that would mean that you're dividing 3 by 3 to get 1. Or multiplying 3 by 1 over 3 to get 1. But then when you go to this side is 4 units long. And if you divide it by 3 or multiply it by 1/3, it should be smaller. But when you look at the other triangle, the corresponding side also measures 4. So these are not similar. Not similar. Ok, estos dos triángulos no son similar porque si comparo este lado a este lado, ¿ok? Este mide 3, lado QR mide 3 y el lado que corresponde, el lado TU, mide 1. Eso quiere decir que para que sean similar, este lado se está dividiendo por 3 para coger 1 o multiplicando por 1 sobre 3 para coger 1. Pero cuando comparamos este lado PQ con este lado que corresponde ST, pueden ver que no cambió de tamaño, así que no pueden ser similar, porque no multiplicaron 4 por 1 sobre 3 o no dividieron 4 por 3. All right, moving on to the next example. All right, again, just from looking at it, if you just look at it, they look similar. Let's try and make sure I'm trying to make your life as easy as possible, as well as mine. So let's only examine the horizontal and the vertical lines, and that should give us enough information, okay? So if you look at the smaller the smaller pentagon, okay, side JS measures 3 and side JN measures 5. Okay, so that would mean 3 times what equals 5? N has to equal 5 over 3. Maybe I should have used the letter K. But anyways, the scale factor that you're multiplying by is 5 over 3. So let's check if I get the same, if this side is, if I could verify that the same thing is happening. Sorry, I can't talk. Let's check if I could verify that the same thing is happening on the vertical side. Okay, so on this vertical side, segment JP measures 1, 2, 3, 4, 5, 6. Okay? And segment JK measures 7, 8, 9, 10, right? 10. So let's test out my theory. If I multiply 6 by 5 over 3, will I get 10? Yes, I will, because you get 30 over 3, which when you simplify that equals 10. So both the horizontal side as well as the vertical side are being multiplied by 5 over 3 to get the to go from the pre-image to the image. So yes, they are similar. All right. Para comprobar que las dos figuras son similar, lucen similar, para comprobar lo que hice primero, chequear, comparé el segmento JS al segmento JN. JS mide 3 y JN mide 5, así que 3 multiplicado por ¿cuál número me da 5? 3 multiplicado por 5 sobre 3. Así que si las dos figuras son similares, eso tendría que decir que el lado JP, que mide 6, si lo multiplico por 5 sobre 3, como hice aquí, me debe dar la medida del lado JK, que mide 10. Y sí, cuando multiplico 6 por 5 sobre 3, me da 10. Así que el lado horizontal y vertical, los dos se están multiplicando por el mismo número, 5 sobre 3. Con comparar los lados horizontal y vertical en casi todos los ejemplos, eso va a ser suficiente para poder responder si son similar o no. All right. All right, so look, are these two similar? Don't even waste your time. They obviously don't even look alike. So no, they're not similar. Okay? Estos dos triángulos obviamente no son similares, no lucen igual, así que no gasten el tiempo, no es necesario hacer calculaciones porque no son similares. All right, here in this one they're comparing this parallelogram to the bigger one. The little one is harder to see, so that's why I outlined it in blue. All right, so CDEF to TUVF. CDEF is the big one, all right? So let's do the same thing I just did, all right? So let's compare DE to UV. All right, DE is 1, 2, 3, 4, 5, 6, all right? And UV is 3. So, I mean, that would obviously make the scale factor 1/2, okay? 6 times 1/2 is 3. All right, now let's check another side. Okay, look what I'm going to do here. Let me change the color to red. Okay, you may or may not remember this from middle school, or I'm not sure if we've done it in this class, but the height of a parallelogram, if you look at this big parallelogram, the height, you measure it like this. It's got to be perpendicular to one side. So I could just look at this line and compare it to this line right here of this smaller parallelogram. All right, so the height of this parallelogram is 4, and the height of this parallelogram is 2. So yeah, obviously that one's also being multiplied by 1/2. All right, so yes, they're similar, and the scale factor equals 1/2. ¿Ok? Si estos dos paralelogramos son similar, ¿ok? Comparé este lado DE al lado V, y lado DE es 6, V es 3. Así que el factor de escala tiene que ser 1/2, porque cuando multiplico 6 por 1/2 me da 3. Y después comparé la altura del paralelogramo. La altura se coge con una línea perpendicular a una de las bases del paralelogramo. ¿Okay? Esta línea perpendicular mide 4, y lo comparé a esta línea perpendicular en el paralelogramo más chiquito, que mide 2. Así que obviamente la altura también se está multiplicando por 1/2 para coger la altura de este paralelogramo. Así que sí son similar. Y el factor de escala es 1/2. Okay, that's the first section that I had to go over. Here's the second section. The second section is basically the same thing, except that there's more than one transformation happening. All right. On your homework, I think I kept all the questions like this so that they only have 2 transformations, because there's some that have 3, but I think I only put them to have 2 transformations. So what I mean is this: if you look at this picture, not only are they making not only are they making parallelogram ABCD smaller, but they're also moving it to the right and down. Okay? If this looks like a lot of work, it's not, because on your homework, the questions like this are going to be multiple choice, and the answers are pretty obvious, all right? They're pretty obvious. If you understand, like what I was saying earlier, that to make it smaller, you multiply by a number less than 1, and if you could see that this is moving to the right and down, you should be able to pick out the answers pretty quickly. All right. So what they put here are the coordinates, the original coordinates, and then the coordinates after a dilation by a scale factor of 1/2 to make it smaller. And then here are after the coordinates once you make it smaller, and then the coordinates after you do this to it. Actually, you know what? What you really got to know for the homework is this part right here that I just noticed, all right? This is what you really got to know. So again, if you realize this, that hey, let's pretend I drew that perfectly, that hey, you're making this smaller like this, and then moving it to the right and down. If you realize those 2 things, then on your multiple choice questions for the homework, you could quickly pick out the answers that hey, to make it smaller, because this is what they're going to ask you for. All right, hey, to make it smaller, I got to multiply by a number less than 1. And I'm pretty sure on the multiple choice that they only have like one answer where you're multiplying less than 1 by a scale factor less than 1. And that also that this means move it to the right. Remember that when you add a number to the x coordinate, it moves it to the right. And when you subtract a number from the x coordinate, it moves it to the left. And the y coordinate controls up and down. If you add to the y coordinate, it moves it up. If you subtract, it moves it down. So if you realize those things, it'll be really easy to just pick the correct multiple choice answer that tells you what transformations you do to parallelogram ABCD to make it parallelogram EFGH, okay? En la tarea, si se dan cuenta que este paralelogramo ABCD se está haciendo una dilatación para hacerlo más chiquito y lo está moviendo para la derecha y para abajo, si se dan cuenta de eso, es bien fácil escoger la respuesta correcta, porque lo que le van a preguntar o pedir en la tarea son las respuestas como esta. Te dan las opciones para la respuesta. Ustedes solamente tienen que escoger cuál es. Así que si se dan cuenta que para hacer una figura más chiquito se tiene que multiplicar XY por un número menos que 1, estoy casi seguro que solamente va a haber una opción que dice de multiplicarlo por un número menos que 1, que sería esta. Y si se dan cuenta que cuando le suman un número al coordinado de X, lo mueve para la derecha, y cuando le restan un número al coordinado de Y, eso lo mueve para abajo. También solamente debe haber una opción que similar a lo que acabo de decir. Así que debe ser bien fácil hacer esta pregunta en la tarea. All right. My point is, you don't have to do all the heavy duty calculations to get the answer. Just a rough idea will get the job done, okay, for the homework. Same thing with this one, okay? So look, it should be obvious on this one that, hey, you got to do a couple things. Actually, this one I believe has 3 transformations. You got to do a reflection to make it look like this. So a reflection over the y-axis, which if you forgot the rule for that, I'll remind you because I used to say it all the time. To reflect over the y-axis, you make x the opposite sign. And to reflect over the x-axis, I make y the opposite sign. It's always the other letter that you change to the opposite sign. So again, to reflect over the y-axis, I got to make x the opposite sign. Anyways, once you reflect over the y-axis, you got 2 more moves that you got to make. You got to do a dilation to make it bigger, and you got to move this trapezoid to the right and up. To the right and up. All right, so let me show you the answer so you can see what I mean. All right, you got to do a reflection. You got to do a dilation. Oh, I guess I'm wrong about moving it to the right and up. Wait a minute. Oh, my bad. Now I realize why I said it wrong, because they're starting with this is what happens when you don't read the directions, kids, like your teacher. All right, it said to start with trapezoid PQRS, and I didn't bother reading the directions because that's how I roll, and I just looked at the diagram and thought they were starting with this one. All right, but no, we're starting with trapezoid PQRS. So you still do that reflection, and then apparently there was no translation needed. All right, you just do a dilation, dividing the top and the bottom by 3, and that makes it smaller. Again, just to repeat, as long as you realize that you got to do a reflection over the y-axis and then make it smaller, there should only be one answer choice for each of these, and it should be obvious what the answers are. It's not necessary on the homework. I'm pretty certain it was not necessary for you to get all the coordinates and do all the detailed calculations. All right, it should be easy. Ok, así que en este problema estamos empezando con el trapezoid PQRS. Lo tenemos que hacer una reflexión sobre el axis de Y. Recuerden que para hacer una reflexión sobre el axis de Y se cambia X al signo opuesto. ¿Ok? Y después de eso, una dilatación para hacerlo más chiquito. Si se dan cuenta que se está haciendo una reflexión sobre el axis de Y una dilatación por un número, se está multiplicando XY por un número menos que 1 para hacer la figura más chiquito. Con simplemente eso pueden hacer la pregunta, porque creo que las respuestas son bastante obvias. All right. Same thing. I put the answers because we're actually almost done with this lesson, but I put the answers because I think it's easier for you guys to get what I'm trying to say if you just look at the answers a second. All right, so the answer choices are multiple choice on the homework. So our starting point is ABC. We're starting with ABC, which is this one. So obviously you got to reflect it over the y-axis to get it to look something like this. All right, that's what they're saying in step 1 here. And then after you do the reflection over the y-axis, you got to move it down 6 units. And that's it. Ok, en este primero se tiene que hacer una reflexión de triángulo ABC sobre el axis de Y y después moverlo para abajo. En el segundo paso. Recuerden que cuando le restan un número a Y, el coordinado de Y, eso mueve la figura para abajo. Y en number 6, it's hard to tell, but we got this shape, which is a trapezoid, compared to, let me use a different color, compared to this shape. All right, so obviously you got to do a reflection Wait, we're starting. Let me. Okay, we're starting with the red one with trapezoid ABCD. So obviously you got to reflect it over the x-axis, which is this move right here, step one, and then do a dilation to make it bigger, and you make it bigger by multiplying by a number greater than one. In this case, they're multiplying by two. Again, on the homework, the answer choices should be obvious. All right, as long as you have a basic understanding, the answer choices will be obvious. Okay, estamos empezando con trapezoid ABCD y primero se tiene que hacer una reflexión sobre el axis de X, cambiando el coordenado de Y al signo opuesto y después una dilatación multiplicando por un número más grande que 1 para hacer el trapezoid más grande. And these are the last two examples. Gotta hurry up. Okay, so they're starting with triangle CED. So again, the first step is to reflect it over the y-axis. That was step one. Reflect over the y-axis. And the second step is to do a dilation where you make the triangle smaller by multiplying by a number less than 1. Okay, aquí una reflexión sobre el axis de Y, el primer paso, y el segundo, hacer una dilatación donde hace la figura más chiquito, multiplicando X y Y por un número menos que 1. And in number 8, we have pentagon. Okay, we have a pentagon ABCDE, which is this one over here. Pentagon ABCDE. Okay, they're doing a reflection because it has this wacky side over here. So they're first reflecting it so that that longer side will be like that. I didn't draw it too good, but and then after that they gotta make it smaller and move it to the right and down. Okay. Aquí primero hicieron una reflexión, después una dilatación para hacerlo más chiquito y después lo movieron para la derecha y para abajo. Again, I tried to keep the homework questions to no more than 2 transformations to not make it overly complicated. All right, the homework should be easy. Traté de dejar las preguntas en la tarea para que no tengan más de 2 transformaciones y sean fácil. All right, guys, so this concludes this lesson. The assignment is in your student portal. It's due by 6 a.m. next class. Hope you guys have a great rest of your day, and I'll see you guys next class.